Hello, my name is Bob Finn, and I'm the Director of Research and Development at Innophos. Today I'm going to be talking about our chelated product line known as Chelamax, and in particular some of our magnesium compounds and the advantages that they have when they are fully chelated. At Innophos, we like to say chelation matters. Having a fully chelated compound means an advantage in both stability, solubility, and bioavailability. And because we understand the advantages of having a fully chelated compound, it's important to understand how you test to prove that your compound is truly fully chelated. Innophos uses a three-step testing process to verify full chelation. One test alone is not enough to prove that a compound is truly chelated. Our first step is to use FTIR, which confirms lot-to-lot uniformity and consistency. Our second step is to use X-ray diffraction. X-ray diffraction does confirm the structure and shows the compound present. And our third step is to use thermogravimetric analysis, or TGA, and that confirms the purity of the structure. This is our three-step testing methodology used on our Chelamax product line, and it is the best in the industry. The standard testing method for nutritional products has been FTIR for a long time. The issue, however, for proving chelation is that the area on the right side of the graph where most of the peaks are is the area where you would need to look for the peaks to prove chelation. So FTIR on its own is limited and inconclusive to prove chelation. It's still a very useful tool for lot-to-lot uniformity, but it falls short of proving chelation. We added in X-ray diffraction analysis because this actually gives you the full structure of the compound. It measures the electron density of both the mineral and the ligand, and is able to show you that the ligand bonds are forming to the mineral, and so you can tell that the chelation has actually formed. Finally, we added in thermogravimetric analysis, or TGA. A ligand will actually decompose at an earlier temperature if it's free versus if it's bound. So we're able to tell whether we have free glycine in our compound or not when we're referring to magnesium glycinate. Based on comparing both the XRD and the TGA, we have conclusive data that shows that our compound is in fact fully chelated, and we can literally draw the structure from the XRD compound. FTIR is still useful for lot-to-lot uniformity, but it's these three test methods together that prove chelation. Now that we've proven our compounds are fully chelated, we set out to compare them versus other leading products in the industry. In this test, we compared our magnesium bisglycinate in an in vitro absorption study versus another leading competitor, Albion. Our Chelamax Magnesium Bisglycinate was 35% more absorbed in this in vitro environment, proving that our full chelation does show an advantage. Another advantage of our process is a higher density product that is produced. When using our Chelamax Magnesium Bisglycinate, we can produce a 00 capsule with 120 milligrams of elemental magnesium. The market standard is a 000 capsule with only 100 milligrams of magnesium present. So our increased density allows for more magnesium in a smaller capsule format. Our Chelamax magnesium citrate is also fully chelated. Magnesium citrate can be useful for certain applications like gummies and ready-to-drink beverages, stick packs. So we tested it in an in vitro absorption as well, and we found it to be over 5 times more absorbing than a magnesium oxide source. Innophos has been building the science on chelation for many years now, starting with our first white paper to prove chelation and building on that into in vitro absorption and bioaccessibility. All of these are still found on our website at innophos.com. Thank you for your attention today, and remember to ensure that your minerals are truly chelated by purchasing Chelamax minerals. Thank you.